We're not going to be looking at long division of polynomials. There's no difference between really long division and division in arithmetic. Just have to be a little bit more careful because it's more detailed. And I would look to say, how many times does 15 go into 23? You would say 1, right? Then what would you do? 1 times 5 is 5. 1 times 1 is 1. Then what's the next step in the process? Subtract. And see, it changes the sign. So it was a positive 15, now it becomes a negative 15. But they didn't tell us that when we were learning how to divide. We just said subtract, and we believed them, right? But we didn't have negative numbers. And then this was an 8, and then you bring down the 1. And then you look at how many times does 15 go into 81. Well, I'd look at 10 is certainly 8 times. But 15, no, it's less than, right? 5 times 5, 25, 75, yep. And then 5 times 5 is 25. 5 times 1 is 5, add 2. And then you subtract, which changes the sign. 6, bring down the next. And then 15 divides 65 4 times. So now again, 4 times 5 is 20. 4 times 1 is 4. Add 2, 6. Then you subtract, and you have a remainder of 5. Now, what would you do? If you're in arithmetic, you say, well, it's 154. And 5 over 15. And then you reduce the 5 over 15. If you're talking about arithmetic, this is 154 plus an additional 5 over 15, right? So it's 5 over 15 more than 154. So this is an alternative way of writing an answer. We'd never do that in arithmetic, but we will do that in algebra. You're going to have what we call the quotient. That's what this guy is here. Quotient plus the remainder. This is your fractional part. And in arithmetic, you just slam them together because that tells you you're going to go 154 units and an additional 5/15 units. But in algebra, you don't have that luxury. Processes in algebra are not much different than processes in arithmetic. So that as we go down through and I take a look at this problem, what would I do? First question I ask myself is this. What you want to do is you want to begin to reduce down. Here we're reducing down sizes of numbers. So I'm taking a 23 and I need to get what's left over smaller than 15 so I can bring the next number down. Here what we want to do, instead of reducing the size of the number, we reduce the degree of the polynomial. It's based on degrees, not numbers. Because that's what makes polynomials different than arithmetic numbers. So I need to reduce down from a degree 2. So what do I ask myself? I ask myself this question. Because this is my divisor, just like I did up here. What do I multiply 15 by to get the largest number I can that's not bigger than 23? And sometimes we have to think that through. So I ask myself this question. if I'm reducing down to by degrees, what do I multiply x by to get 2x squared? What do I multiply x by to get 2x squared? What would it be? 2x. I would look at this and say it would be x times something equals 2x squared, because that's what's going to reduce down by degree, by the way, because when we subtract, it would be 2x. So that's like the 1 I put up, that's part of my quotient. 2x is part of my quotient. So then I'd say to myself, okay, I said it was 2x. So what did we do? We took the 1 times the 5 and the 1 times the 1. Here, we're going to do it by degree first. 2x times x is 2x squared plus, because there's a plus here, 2x times 1 is 2x. Now, what did we do with the arithmetic? Subtract. It changes all of the signs. What you find that I never write over top on an original sign. That way I know I've changed everybody. So what do you notice? Plus 2x squared minus 2x squared is 0. He bit the dust. And my new part is an x minus 1. Is this of smaller degree than what I started out with? I started out with a degree 2. This guy is a degree 1. This guy is a degree 1. Until I get something smaller than a degree 1, I keep going. So I ask myself the same question. What do I multiply x by to get x? So that would say x times something equals x. What does that something have to be? 1. Now that's your part of your quotient. And it is a plus 1. So then I come back over here. Plus 1. 1 times x is x. 1 times plus 1 is plus 1. And then what do I do? Subtract, and it changes all of the signs. The x is reduced out. That means I've now dropped it down another power, another degree, and I'm left with minus 2. That's my remainder. So what's my answer? My answer is 2x plus 1 plus negative 2 over the divisor. Just like I did with arithmetic. No difference. Now, if you wanted to say, does that minus make this a minus? Yeah, theoretically, if you want to do it that way, you could do. In college algebra, by the way, sometimes we're only interested in the quotient. Sometimes we're only interested in the remainder. Sometimes we're interested in both. Depends upon what we're doing. Depends upon what we're doing. Questions?
So why wouldn't it just be minus like 2x plus 1? Is it always plus the remainder?
Yeah, but you could put the minus in front. So in other words, if you wanted to write it this way,
it's fine.
That's fine too. I'm usually on a roll, and I usually say plus the remainder, and the numerator happen to be negative. I'm not done. If my divisor is a degree 1, I'm not done until I end up with a remainder that's degree 0. It's always got to be smaller than the divisor, but it's always by degree. It's like I'm not done with this long division until, if I've added no zeros, right, for decimals, until the number I come out with is smaller than 15. So we operate by degrees. So here we go. Now, what do I multiply 2x by to get 4x cubed? 2x squared. So here we go. 2x squared times 2x, 4x cubed, 2x squared times 3 plus 6x squared. Now what do we do? Subtract. The cubes drop out, so that means we've reduced to the degree. And I get a 6x squared, and then you bring down the 7x. Just like you do in arithmetic, you bring down the next thing. What do I multiply 2x by to get 6x squared? 3x. So this is a plus 3x, because this 6 is plus. 3x times 2x is 6x squared. 3x times plus 3 is plus 9x. And then what do? Subtract. Now the squareds drop out. This is a minus 2x. Bring down the minus 3. This is degree 1. Your divisor is degree 1. That means I'm not done. What do I multiply 2x by to get minus 2x? Negative 1. Minus 2x times 2x, minus 2x, minus 1 times plus 3, minus 3, and then what do? Subtract. Minus changes to a plus, minus changes to a plus, 2x's drop out, minus 3 plus 3 is 0. It divided evenly. So your answer is 2x squared plus 3x minus 1. And you don't need to put remainder 0, because if there's no remainder, there wouldn't be anything hanging off the edge, right?